What is up, everybody? It's Dan from SageMathTutoring.com, and here's another video where I'm going to tackle a few problems from one of my students' review sheets for a test. So let's just get started. This is like systems of equations, basically. The State Fair is a popular field trip destination. This year, the senior class high school A and the senior class high school B both have planned trips there. Senior class and high school A rented and filled 8 vans and 8 buses with 240 students. High school B rented and filled 4 vans and 1 bus with 54 students. Every van had the same number of students in it as did the buses. Find the number of students in each van and in each bus. Yeah, so basically we could say find the number of students in each van and in each bus. So we could say V represents the students in the van. And we could say B represents the students, that's number sign, pound sign, meaning number, in the buses, okay? And I think that's, probably most people would agree with that, those variables. So looking at high school A, the senior class in high school A rented and filled 8 vans, so that's going to be 8 vans times V students, okay? Plus 8 buses times B students equals a total of 240 students. High school B, that's going to be 4 vans times V students plus 1 bus times B students. I'm just going to write B equals 54 students. Okay, now we want to know the number of students in each van and each bus. In other words, solve for V, solve for B. Now, in this case, my student and I have been using something called elimination to solve systems of equations so far, but this is the first time where I'm seeing that the substitution method might be a little better. And the reason why a different method, the substitution method, might be better is because this B is by itself, and what that means is we could immediately solve for that B right now. We can say B is equal to 54 minus 4V, and therefore, what that means is anytime we see B, and by the way, I did that by subtracting 4V from both sides, right? So anytime we see B, we can replace it with 54 minus 4V, which is exactly what we're going to do right here. So we're going to say 8V plus 8 times not B, but 54 minus 4V. And that's going to equal 240. Distributing, we're going to have 8 times 54, which is 432 minus 32V equals 240. 8V minus 32V is negative 24V plus 432 equals 240. You could then subtract 432 from both sides, and you would have negative 24V equals negative 192, and negative 192 divided by negative 24 is positive 8. Now that is a good sign that we got a positive number. So apparently there's 8 students per van, okay, 8 students per van. So the question now is, okay, if there's 8 students per van, how many students are there per bus? In other words, what is B? Because we just solved V, now we want B. Well, the good news is we could really just use this yellow box equation. I mean, because we kind of modified this equation here, we turned it into the red equation, and this red equation is kind of the perfect equation to use right now. So we have B equals 54 minus 4 times 8, right? So it's 54 minus 32, and 54 minus 32 is 22. All right, so there's 22 students per bus. Now, I strongly encourage my student at home to always double check, make sure you're answering the actual question. The question is find the number of students in each van and in each bus. Okay, yes, we did answer the question. There's 8 students in every van, 22 students in every bus. All right, so that's that. Problem number 8. Senior class high school A, blah, 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 B, separate trips, blah, blah, blah. Senior class high school A rented and filled 1 van, 6 buses. Okay, another van and bus problem. Okay. 3 is probably the same thing. It's probably going to be the same thing. Same deal. Honestly, I don't even need to do that for my student because my student knows. Just do the exact same thing. Um, it's going to be, uh, you know, V plus 6B equals 372. That's one of the equations. The other equation is 4V plus 12B equals 780. And then basically just do the same thing. Although I will say, let's talk about it. Whatever. I'm being lazy. We're going to talk about this. So, first equation is that. Second equation is this. All right. But here's the deal. The difference is yes, use substitution, but this time what you're going to do is you're going to modify the top equation. You're going to modify the red equation to say V equals 372 minus 6B. And it's that new modified green box equation that is such that you're going to replace V right here with 372 minus 6B. Okay? So for my student who's watching this, just know that that's what you do. But it's this initial setup that's important. It's the recognition that the V is by itself, which means you should probably use substitution now. Because since V is by itself right here, it's very easy to solve for V. In the exact same way that earlier we had a B by itself, which meant it's very easy to solve for B in terms of V, of course, and then take it from there. So that's that. Problem number 9. Brandon School selling one ticket, spring, blah, blah, blah. On the first day, ticket sales sold, okay, senior citizen child tickets, right, 75. 67, second day, right. Okay, my student and I did a problem just like this sort of earlier. And what we did, which was a really good idea, is we just called X the senior citizen tickets. And we called Y the children tickets. And basically, you set up an equation where X represents, we could say, the price, senior citizen. The price, child ticket. And at the end of the day, they want to know what is the price of one senior citizen ticket and the price of one child ticket. In other words, solve for X and Y, right? Well, they give us information that pertains to how much money they brought in. And on the first day, they sold 3 times X and 9 times Y, and they pulled in $75. On the other day, the school took in $67 total, and that's a result of selling 8 times X plus 5 times Y. Okay, so this one is, what makes this one more challenging is it's not obvious what to do necessarily with this because, you can't just do substitution easily because it's not like any of these variables are by themselves. Like earlier, obviously we were just talking about how V was by itself, so that's a sign you might want to do substitution. Well, that's not happening here. It's also not the case that we have an easy elimination path either. For example, if we had something like X plus Y equals 5 and X minus Y equals 2, well, clearly we could just add the top thing to the bottom one, right? And then these would cancel. You'd have 2x equals 7, and then you would just take it from there, right? But that's only easy when you have a plus y minus y stacked directly above each other. We don't have that, right? This one's hard, actually, right? This one's a little crazy. But what you have to do is you just have to make a decision. You're going to have to use the elimination method, but you must make a decision. Which variable do I want to get rid of? And honestly, it doesn't matter. But let's just choose to get rid of the x's, okay? And one way of doing it is you can force this guy. Think about 3 and 8. Least common multiple of 3 and 8 is 24, if I'm not mistaken. So what you want to do is you have a target. You want to turn this into a 24x. And you want to turn this into a negative 24x. Because if you could turn this guy into a 24x and this guy into a negative 24x, well, once you add the top equation to the bottom equations, they're just going to cancel, and all the x's are going to be gone. So the question is, well, what do I need to multiply this top equation? What do I need to multiply 3x by in order to get 24x? I need to multiply 3x by 8 in order to get that 24x. But you know that you can't just multiply the 3x by 8. if you're going to multiply the 3x by 8, you're going to have to multiply the entire equation by 8. You can't just multiply one thing by 8. Okay? So we're going to do that. We're going to do that soon. Now, the bottom equation is this. And we want to turn that 8x into a negative 24x, right? So how do you do that? Well, you'd have to multiply 8x by negative 3. Now, as you understand, I'm sure, you can't just multiply the 8x by negative 3. You're going to multiply the entire thing by negative 3, right? Now, what does that result in? Well, what that results in is two sort of new updated equations. The first equation is literally going to be 24x plus 72y equals 75 times 8, which is 600. This guy right here, it would be negative 3 times 8x, which is negative 24x, which is what we want, remember. Negative 3 times 5x is negative 15y, negative 3 times 5y. Negative 3 times 67 is negative 201. Now we're ready to add the top equation to the bottom equation, and in doing so, these cancel. 72y plus negative 15y is, all right, so 72y plus negative 15y is 57y, and that's going to equal 600 minus 201, which is 399. And then when we divide 399 by 57, believe it or not, we get, I believe, 7. I think 7, yeah, so 7, okay? So how about that? Wasn't that awesome? Wasn't that not annoying on opposite day? So that's y equals 7. So then the question is, well, what does x equal? Well, you know, you got your y equals 7, that's fine. By the way, that's the child ticket, but now we want the senior citizen ticket. Well, you just pick any of the equations. It doesn't matter which one you pick. You could pick the top one, you could pick the bottom one, but what we're going to do is we're going to pick the top one, and we'll bring it down here. So we'll say 3x plus 9y, but we know what y is. It's 7, so it's 9 times 7. That equals 75. Of course, 3x plus 63 equals 75. Subtracting 63 from both sides is going to be, I believe, 12. I think I got that. I'm good enough to do that without a calculator. And then x equals 4. Okay, so there we go. We are done. Just make it clear to the teacher that you know that this is the senior citizen's price. The senior citizen price is $4. The child ticket price is $7. So that's that. All right, looking at problem number 10. All right, so we got Matt and Ming are selling fruit for a school fundraiser. Customers can buy small boxes of oranges, large boxes of oranges, blah, blah. Matt sold 3 boxes of oranges, 14 large boxes, or small boxes, 14 large boxes, for a total of that. Ming sold 11 small, 11 large, for a total of that. All right, so honestly, this is going to be like the same thing as the last one. It's the cost of one small box, cost of one large box. We're going to be boring, and we're going to use x and y again. X is the cost of a small box. Y is the cost of the large box. And once again, two equations that have to do with money. We know that, Matt, we'll focus on Matt now. He sold 3 small boxes, so that's going to be 3x plus 14y. And that's going to equal 203. Ming sold 11 small plus 11y, and that's going to equal 220. Now, once again, we have a scenario where it's not obvious whether or not we should do elimination, substitution, or whatever. All right, so these are the two equations that you want to use without question. However, I'm seeing an opportunity. By the way, could you use the elimination method to do something similar as we did with the last problem? Yes, you could totally use the elimination method and do stuff like this. We turn that to 24x, turn that to negative 24x. Well, the bottom line is we could turn that into 33x, and we could turn that into negative 33x, okay? That is a possibility. However, I have experience, so because I have experience, certain things pop out at me, okay? And I don't expect my student to necessarily see this right away, but I know that 220 is a multiple of 11 because 22 is a multiple of 11. 22 is literally 11 times 2. So that means that 220 divided by 11 is 20. all right? Now, what am I getting at? What I'm getting at is that you can literally divide all of the terms in this entire equation by 11. Now, what does that result in? That results in a wonderfully simpler equation. 11x divided by 11 is just x. 11y divided by 11 is just y. 220 divided by 11, I already said it, it's 20. So I'm going to say, let's work with this thing, because honestly, this is the same equation as that thing. But this is a simpler version of that equation that's easier to think about and easier to work with. So I'm actually going to get rid of this equation because we just updated it to something that's a lot nicer to think about. Now, why am I doing that? Well, first of all, I'm doing that because it makes it easier on my brain. Honestly, this is ugly. It was ugly. This is not. This is like, oh, x plus y equals 20. That's nice, right? Very easy to think about. But the other reason I'm doing it is because the elimination method, you know, it's a little bit clunky, right? Look at all this. It's terrible. No one wants, if you don't have to do the elimination method with this weird complicated stuff, don't. By doing this, I've made it easy for us to just do the substitution method. I can solve for x and just say x is equal to 20 minus y. How did I do that? Well, you just subtract y from both sides. Done, right? So, could I have solved for y as well? I could have been like, y is 20 minus x. Yes, right? Basically just pick one of these two, solve for it because it's by itself, right? X equals 20 minus y. Now, do you agree, those watching, do you agree that what that means is anytime I see an x, well, I could replace it with 20 minus y, right? Isn't that what it means? Well, that's what we're going to do here. We're going to replace this x with a 20 minus y. So we have x equals, or 3 times 20 minus y plus 14y equals 203. And then we literally just solve for y at that point. So we have 60 minus 3y plus 14y equals 203. We would then have 60 plus 11y equals 203. 203 minus 60 is 143. And then 143 divided by 11 is 13. All right. So y equals 13. And now we want to find x. Well, remember how I said when you're using substitution, you kind of have like the updated formula that you already updated from before. That's probably the best candidate to use if you're going to solve for x now, because it's like x equals blah, 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 blah. So we're going to say x equals 20 minus 13. And that, of course, equals 7. So those are your answers. So you want to make it very clear, y equals 13. So make it clear to your teacher that you know that the cost of a large box is $13. And x equals 7. So what that means that your teacher needs to know is that the cost of a small box is $7. You got to make that clear in your answer. All right. A boat traveled 336 miles downstream and back. The trip downstream took 12 hours. The trip back took 14 hours. What's the speed of the boat in still water? What's the speed of the current? Okay, now this might be unnecessary. It might be overkill, but anytime there's a trip there and back problem, I like to do the rate times time equals distance. Me personally, I like to fill out the chart, okay? There's a chart where there's the trip there and there's the trip back. Well, the rate, and this is multiplication. The boat traveled 336 miles there and back. Okay, fine. Just fill that in. This is a good way to wrap your mind around the situation. The trip downstream took 12 hours. Okay, so that's this one. The trip back took 14, right? What is the speed of the boat in still water? Okay, we're going to call that S. That's the speed of the boat in still water and the speed of the current. Now, if you're going downstream, that means it's going to be the speed of the boat in still water plus the current. That's the total speed that they went downstream in general. If you're going upstream, well, that's going to be the speed of the boat minus the current right there, right? So that's helpful, okay? Now, let's look at the top row. The top row gives us an equation. That equation is S plus C times 12 equals 336. All right? The bottom equation also gives us, or the bottom row gives us another equation. That equation is S minus C times 14 also equals 336. Now we're going to do a move that you might not be used to for those of you watching. I know you're all used to being like, oh, 12 distributed into the S plus C, and then you take it from there. Now that wouldn't be wrong necessarily, but the bottom line is you can divide this by 12 right away, okay? And that would get rid of that. And then that would cause us to have a beautiful, simple equation because the S plus C is left over. And all you have to do is say, okay, well, S plus C equals 336 divided by 12. Well, 336 divided by 12 is 28. So we got 28 here. So isn't that a nice equation? Basically what we're doing is we're constructing the equations that we're going to use to solve the problem. So this is the first equation that we're going to use. Now, as you would probably guess, you could do literally the same thing over here where you divide both sides this time by 14. Right? And then you're going to have your S minus C equals 336 divided by 14. 336 divided by 14 is 24. And now you have your second equation, which is going to be very useful. So what we're going to do is we're going to stack the equations. We got S plus C equals 28. We got S minus C equals 24. Obviously, we should use the elimination method because when you add the bottom equation to the top equation, the C's will cancel. So that's exactly what we're going to do. So we're going to have 2S equals 52. 52 divided by 2 is 26. So the speed of the boat in still water, which is S, is 26. All you then have to do is pick one of the equations. I say we'll go with the bottom one, who cares? We're going to find the current now. So it's S minus C equals 24. Clearly that is 26 minus C equals 24. You can just see just by common sense, C is equal to 2. So the current is, was it miles? Okay, yeah, it's miles. So it's 2 miles an hour, right? Okay, so these are the answers. The speed of the boat in still water is 26 miles per hour. The speed of the current is 2 miles per hour. For my student at home watching this, I would strongly advise that you use those units, literally say miles per hour. Otherwise, the teacher might take off a point, all right? So once again, going back, asking yourself, what are they asking for? Make sure you're answering their question. Anyway, that's how you do all these problems. For my student at home, please devote, I would say, I hate to say it, but at least 2 hours to studying. It's kind of annoying, I know, but you could always break it up in 20-minute segments or something, And then practice. Use this video, use the answer sheet that the teacher provided. Practice the problems over and over until you get them right without help. Good luck. All right. For the rest of you watching this, if you're watching it, good luck to you as well. This is always kind of tricky stuff. I will say, trip there and back problems featuring speed, time, and distance. This table is really, really useful. I'm just going to put it out there. You just put up the table, set up this labeling, label it thusly, label this, trip there, trip back, fill in the cells that you know the values for, and then take it from there. All right. Anyway, good luck, everybody, and I will talk to you later. Take it easy.